Welcome to Module 5, Lesson 4, Circle Theorems. So here's some just basic circle vocabulary that you'll need during this lesson. Right, the radius of a circle is the segment from the center to any point on the circle. The diameter is a segment passing through the center, touching 2 points on the circle. And the formula for the diameter is 2 times r. A central angle is an angle whose vertex is at the center of a circle. And an inscribed angle is an angle whose vertex is on the circle with 2 sides as chords. The arc is a portion of the circumference of a circle. A minor arc is less than 180 degrees, and a major arc is more than 180 degrees. The circumference and area formulas are provided to you on the reference table on the SAT. So we'll be needing those formulas today, so make sure you have your reference table handy. We're going to look at calculating arc lengths of a circle, and you can use central angles to calculate arc length. And you can use that by substituting into this proportion here. The central angle over 360 equals the arc length over the circumference. So let's take a look at an example. In circle O, OA is equal to 6, and the measure of angle COA equals 100 degrees. What is the length of the arc AC? So they give us a central angle, and they give us the radius, which is 6. They want us to find this arc here, AC. So we're going to use our formula and substitute in. So the central angle is 100. So we'll put 100 over 360 equals x. That's the arc length. That's what we're looking for over the circumference, right? So the circumference is 2 pi r. So I just substituted 6 in for r here. So now we can simplify this, and we get 100 over 360 equals x over 12 pi. Then we can cross multiply, and we get 360x equals 1,200 pi. Then we'll divide both sides by 360, and you get x equals 10 over 3 pi. So the length of arc AC equals 10 over 3 pi, or if the question asks you to round, it's approximately 10.47. Please pause this video and work on the Lesson 4 Level 1 problems in the workbook. In Level 2, we'll look at calculating sector areas. You can use central angles to calculate sector areas. So the formula is very similar. It's the central angle over 360, but now we'll set that equal to the sector area over the circle area. So let's take a look at an example. In circle O, OA is equal to 6, and the measure of angle COA equals 100 degrees. What is the area of the unshaded sector? So this is the same circle that we just looked at in level 1 where we found the arc length. Now we're going to find the area of the sector created by the central angle. So that's that sector here in white, the part that's unshaded. So we'll substitute into our formula. We'll put 100 over 360 equals x, right? The area we're trying to find, over the circle area, which is pi r squared, and we just substituted 6 for r. Simplifying, we get 100 over 360 equals x over 36 pi. We can cross multiply now. We get 360x equals 3,600 pi. Dividing both sides by 360, we get x equals 10 pi. So the area of the unshaded sector is equal to 10 pi. Please pause this video and work on the Lesson 4 Level 2 problems in the workbook. In level 3, let's look at a multi-step problem-solving question. So in the circle shown, point O is the center, and the shaded area is 3/8 of the area of the circle. What is the value of x? So they want us to find this central angle, and they tell us that the shaded area is 3/8 of the area of the entire circle. So we can use this formula here, and we can put x over 360 equals 3/8, right? They give us that ratio there. It's 3/8. So now, if we multiply both sides by 360, we get x equals 3/8 times 360, which is 135 degrees. So the value of x here, our central angle, is 135 degrees. Now let's take a look at another example that involves a couple more steps. In circle P below, diameter AC and radius BP are drawn such that the measure of angle APB equals 110 degrees. If the area of the shaded region is 7 pi, right, this area here, what is the diameter of the circle? Okay, so there's a lot of information here, and there are a lot of things that we're going to have to find out before we can arrive at our answer of finding the actual diameter. Okay, so we're going to use our central angle over 360 equals sector area over circle area formula first, right? So we know the sector area is 7 pi, right? But what is this angle? We're going to need this angle. Well, if you notice, right here on this line, APC, 110 degrees and this missing angle have to equal 180 degrees because they make up a line, and a line is 180 degrees. So if this angle here, if angle APB is 110 degrees, that means angle BPC has to be 70 degrees. So we'll put 70 degrees over 360 and set that equal to 7 pi over x to find the circle area. Now, why would we want to find the circle area when we want to find the diameter? Well, if we could find the circle area, that will help us find the radius. And if we have the radius, then we can find the diameter. So cross multiplying, we get 70x equals 2,520 pi. Dividing both sides by 70, we get x equals 36 pi. So that means the area of the entire circle is 36 pi. So now we can set the area formula equal to 36 pi. We get pi r squared equals 36 pi. So that means r is equal to 6. So that's the radius. And some students might stop here and be like, okay, I'm done, I have my answer. But 6 is the radius. They want the diameter. So what do we know about the diameter? The diameter is 2 times r. So that means the diameter has to be 2 times 6, which is 12. Please pause this video and work on the Lesson 4 Level 3 problems in the workbook. Once you're finished with the problems in the workbook, please move on to the next video for Lesson 5.